Hey, welcome to Introduction to Autosync Part 3. And if you've been following what's been going on, you'll see that I'm now working on the third of our three images. All three of them are showing green because I have control points in place on each of them. I've actually placed 7 control points in place on this image so far. And I wanted to demonstrate this automatic correlation of control points. So what I'll do is I'll just drag our selection cursor across to say here on the 2 images, which is probably going to be about here somewhere. Now if I select to drop a control point on this point here, watch what happens in the corresponding box to the right. Absolutely nothing, which is really handy because it worked perfectly a moment ago. It should be aligning a point, placing a point on this particular tree. Let's try that again in a moment. Don't you just love it when a program works to really help you? Okay, so let's try that again. We'll pick a point on this particular photo. And hooray, it's actually put a point on the corresponding photo to the right. It looks to me like it's a bit out of place, so we might just drag that up a bit and drop it where I think it's the right place. But you can see that the system has made an attempt to estimate where it thought the point should go and put the point in the corresponding place. So I'll just finish off this this pair of images and come back when we've done some more adjustments. Okay, after a fair bit of fiddling around, I managed to get the solution for this third photo down to under 2 meters, and now what I'm going to do is use another function of the program to automatically generate some control points based upon the ones that I've put in place. And this automatic point matching system is accessed by using this icon on the toolbar, or you could probably use one of the drop-down menu selections, but I'll run it from the toolbar and it will now go through the active area of the photos and compute what it thinks are matching points across the photo based upon the ones that I've already created. So I'll let that run its course and I'll come back when it's finished that process. Okay, that took about an hour. Because I neglected to tell the computer that what my intentions were, and I only wanted automatic points for this particular image, but it did it for all 3 because I didn't set the other images as being inactive. That's something that I hadn't covered up until now, but I'll just show you quickly how to do that. If you right click on the image and set it as inactive, you'll see that it becomes greyed out. That means that it won't be processed by any commands that process all the images, like resampling or in this case automatic point matching. So I'll do that with both these first 2 images and only leave the image that we're currently working on active. Anyway, now that the automatic point matching has been finished, you'll see that there's quite a number more points scattered across the image in both the reference image and the actual image to be rectified. And you'll notice down the bottom here in the table that after our 10th manually inserted point, there is now a whole range of extra points with the APM prefix. Okay, and you'll see that the X and Y residuals over this side are quite variable. How it manages to think that it's managed to match a point where you have a residual that's 36 meters or not is a bit beyond me, but anyway. So what you can do now is you can actually use this particular icon, these icons on the toolbar, to highlight any points which have an overall error greater than the threshold that you set. So in this case the threshold is set to 3 meters, and you'll see that these overall errors for the points are markedly in excess of that. So what we can do is, if we use this icon, it will actually highlight the images that actually have an error greater than 3 meters. Okay, Now you'll notice that it's actually said that the error for my original control points that I had down to under an RMSE of 2 is now in some cases up to 113 metres. In fact, it's said that all of the control points, with very few exceptions, are above 3 metres. If you scroll down through them, you'll see there's a few that it seems to think, well, there you go, 3 points are less than 3. What we can do is we can then sort them from Z to A, which means the most extreme errors are at the top of the list now, and you'll see that our 3 automatic points, which are supposedly less than 3 metres, are now down the bottom. Let's just go to the worst one of those. Well, that actually looks like it's a fair way out to me. This tree down here is the tree that it seems to think that it's matched on. So those points are not particularly good from my perspective. Let's go back to the top, go back to my manual points, and you'll see that they're actually matching up quite well. These overall errors are still a function of the total number of control points, the automatic points and the points that I've put in manually. So therefore these errors are actually a reflection of the error for the entire image based upon all the points. If I look at some of these points, I can actually find any that are reasonable. You'll see that this area of the photo here matches up to this area here, so this point should be up about here, so it's out by a significant distance. The automatic point matching can be accurate, or it can be somewhat less than accurate, but if we go through and check some of these points, that one doesn't look like it's too bad, but it's pretty hard to make sure of exactly how close these are at this sort of scale with this sort of resolution. It would appear that most of these points are fairly well out of position. I'm not totally au fait with the algorithms that are used in here, but I have noticed that this automatic point matching varies in its accuracy. I don't think that there's terribly many on this particular photo that would be particularly useful. So what I might do is, now that I actually have the list sorted back in, well, I can sort them back into point order, I suppose, and then just delete all the automatic points that have been put in place and go back to my original sub 2 metre RMSE. And the simple way to do that is to just highlight the first point, drag down, and it will slowly highlight the points all the way to the bottom. Having done that, we can simply select, right click, delete selection. And it looks like we've missed a few, which is not entirely surprising. Okay, now I've removed those points, we've got our RMSE back to sub 2 metres. What I can do, just to show you how that system is supposed to work, close these columns up a little bit, is I can rank the contribution of the total error as I did before using the sort function, and you can see that the total contribution and the total errors for each of my manually inserted points is shown. I can then change the criteria upon which I'm assessing the points, and then highlight the points that exceed that criteria. The point being that when you have a lot of points that are generated automatically or manually, that then you can actually see the ones at a glance that exceed your criteria, go to them, tidy them up, and then remove them or adjust them until they become more accurate, and therefore improve your overall result. Okay, so now we've covered the insertion of the control points, some of the features of the program. We've come up with a reasonable error for the 3 photos that we've wanted to rectify, and I can actually show you the results that we obtain from doing a resample. In the output images field here, you'll see that there is one image showing. It's the first one that I had prepared earlier, and if I double click on that, it will actually show up in a preview window. The window arrays will disappear, and you can actually see the result of the rectification in that window. Just to clarify it, I've removed those automatic points so that you can actually see the original control points that were set up. I'll just zoom to the area of the photo, and you'll see that the scale will readjust and that the original points are shown. You'll see that there's some warping in the image as compared to the original image that was unadjusted, and if I use these tools at the top of the menu, I can actually compare the two. I like to use the swipe tool, and I'll just drag that into the window so that you can see it, and it just enables you to use this particular slider to scroll back and forward across the image, and you'll see that there's a good close alignment between the rectified aerial image and the reference image that was used as the source material. So that's quite a nice rectification. There's no obvious movement between those two images as you scroll across. I'll just close that and show you the other options. This is the viewer flicker. You can set it to manually flicker, or you can set it to automatic mode. This is 1/3 of a second, so if I turn it to automatic mode, it'll go back and forward so you can look across and compare the two, or you can flicker it manually on and off at whatever speed you particularly choose to use. This function is a fade and blend percentage function, and you can actually fade between the two images and see any areas of misalignment. So those are the tools that you can use to actually assess the accuracy of your output. Now, as you'll see, we have the first two images set to inactive because of the grayed out icon. I can right click on this and I can tell it to resample, and it will run this particular image. If I hit the resample icon at this point, instead of it resampling all these images, because these are set inactive, it will also just do this particular image. I'll do it the right click method and set that to resample now, and you'll see that a dialog will pop up, and it will actually set about resampling this image and writing it to the same state as the image that we're currently viewing, which is the image number 63, which is the first one in our set of images. I'll come back to when this one has actually completed this process. It'll take a few minutes. Okay, now that's finished computing the resample, and after that happens, it now goes through and computes pyramid layers for the file, and that usually only takes a minute or two. So I'll just leave this running until that process happens so that you can see what the outcome is. And my computer's a bit busy at the moment, so I'll just spread that up a little bit. Generally when it gets to 50%, this the pyramid generation stops, and it'll run through the rest of the process. There we go. Now automatically, if you have the control point generation windows open, it will automatically default to this preview setting. This can also be adjusted using these icons at the top of the screen as well. So you can see that it's now fitted the final output to this window. This is the very edge of the resampled image. So I'll fit the image to the window, right click and then fit to window, and then I can zoom. You can see it's a slightly different location to the other photo. I'll quickly open the swipe function, and you can see that the roads are nicely aligned. The alignment is quite good across the image again. Okay, so that's basically the process. You can pull in quite a number of input images. Don't forget to set these to inactive if you don't want the whole thing to resample at once. Right-click context menus are very useful, and you can then open these output images in whatever GIS package you need. One tip: output them to IMG format. If you output them to a resample format like JP2, you'll find that the resampling process does take a bit longer. I think the program likes to work with them in an uncompressed format of a type of file, and then has to subsequently, once it finishes the resample, write that to a compressed image. Okay, I hope you found that useful.